Hello everybody and welcome to Module 6. This is where we're going to be playing with the photoresistor. You might be asking, what is a photoresistor? Well, a photoresistor, put simply, measures the amount of light and then outputs a resistance based on how much light there is. So if there's more light, there's actually less resistance, and if there's less light, then there's more resistance. We can use this to do cool things such as this. Boop. Let me turn on the light. There we go. To do this, we take an input from the photoresistor to calculate a couple things on the board and output the value to the LED. In this module, I'm going to have two different versions. I'm going to have one more bright or less bright based upon the light value in the room. And I'm going to have a second one, which is where it's simply on off, both of which are down below in the code section, and you are free to copy and use those however you wish. What you will need for this module is you will need a singular photoresistor, a few jumper cables, another couple resistors, and an LED, and of course the board. As for now, let's get onto the whiteboard and we can start working on the diagram. I'm going to very quickly just explain the important parts. I mean, besides this is basically how you should wire it up. Yes, there's better ways to wire it, and you're very free, and I implore you to try to find better ways to wire it and whatnot. But the important bits are as follows. Besides, you got the standard 5-volt power and ground going into these strips. You have the photoresistor here, which is constantly reading in a light value of the room or whatever is, if you put your hand above it, etc. It's reading how much light is in there and giving off a resistance value. That value is put through this cable here into the input A0, analog A0. And the reason that it's important that it's analog is because analog allows us to read a multiple set of values versus just a binary 1-0 on-off type thing. It's essentially useful because, it doesn't want to read if there's light or not. It wants to read what value is a light at, which can help us use it for one of the two examples that I'm going to give later. The board will then do some calculations and say, hey, on pulse width module 9, which is pulse width modulation, allows us to change the voltage on the pin, which is useful for if we want to make it brighter or darker. We're going to say calculate some things, and then on this line, boop, go over to the LED itself and determine how bright or how dark it is based on whatever voltage we want to put on there. If you put it on 8, we would not have that available to us simply because it's not pulse width modulation, so it's harder to be able to change, or you can't change what voltage is on this line. It's either it's the voltage that's going out or there is no voltage going out. This one, you can set it to a certain value, or there's a certain range of values that it can be put to. Other than that, this is basically how you'd wire it up. But for now, I'm going to bring you to the code section, and I'm going to show you two examples of what you can do with this kind of wire up, and just a small little bit of code changes. So let's jump right into that. Okay, so here's the code for the first version of the photoresistor, which is the one where it will constantly be on, but emitting a value that's the opposite of what it is in the room. So if it's really dark in the room, it will be brighter, and if it's really bright, it will be less bright. If that makes any sense. So to explain what I've done, or what we've done, is we have these global variables, the sensor pin, which is going to be A0. That's the one where we are taking in that analog input from the photoresistor. We have the LED pin, which is the pulse width modulation 9, which is what we're sending to the LED. And then we have and I'll explain this part later, it's the constrained max light level. The reason we have the constrained max light level is because when we're reading in from the photoresistor, we're going to get a wide range of values, and we want to constrain those and map them to a different set of values. So for instance, we might get a value as high as, which I'm going to go down to these global variables. We might have something as high as 1023, or we might have something as, low as 0. And the reasoning we have to have this value is because what we want to output on the voltage line is going to be slightly different, and it's going to be a little bit more easy to understand if it's not this insanely wide range of values, but instead somewhere between 250 and 255. So to explain the code, we have the setup with the pin mode, setting LED pin, which is pulse width modulation 9, as we talked about before, is an output, which is we're gonna set this as the output to the LED. The next is used for debugging, and we're setting the baud rate for the serial monitor to 9600 so that we can basically wherever we print, which is down here, these simply go into that output thing, and you can say this is essentially this calculation here is what's outputting in that thing constantly over and over again. So as you move your hand over and away from the light sensor, those values will change. Next, we have the loop, where we have basically three important parts. We have this part, and this part. The other two are just used for debugging, so you don't really need to worry about these as of right now. But at first, we have the light level, which is basically calculated at first using the reading in from that sensor pin, which is coming in from the photoresistor. It reads the voltage on the sensor pin, and then it calls a function here to calibrate to room. And then it writes that whatever it calibrates from in this function, which I'll explain in a moment, into here. The reason I'm using this calculation instead of just putting a light level is simply because if it was just light level, the light in the room would be brighter if the room was bright. And that's not what we want for a night light. That would be a daylight sensor or daylight light. So it's obviously not what we wanted. So by doing it this way, it inverses that. Next, we have calibrate to room. So in calibrate to room, we have the following. We have these two if statements that basically say if it's less than the minimum or if it's greater than the maximum, then you need to set that new maximum to be that amount. And the reason we have that is because a photoresistor can read a lot of different values, very high, very low. And so if it ever goes outside of those bounds, we need to adjust those bounds. Basically meaning that the new maximum will be, the maximum it's read in, and the new minimum will be the minimum it's read in. We initialize it to 0 and 1023 above. But again, if it ever goes higher or lower, we need to adjust those bounds. And then we set light level to be mapped to a constraint of what was the old minimum and maximum, or what was calculated here, into between 0 and 255, which is exactly what is also done here. And then lastly, we just take whatever value it gets mapped here, and we say, okay, put it between a value that's equivalent to be 0 and 255, as close as you can get, which was originally between 0 and 1023, or a larger range of values, depending on if this had to be calculated and changed. Then it just writes that level, essentially to that pin, setting the LED to be that level of brightness. And then next, I will be explaining the other version of the code, which is simply it's on or it's off, instead of a constantly on and changing, adjusting to what the value in the room is at that time. Basically, it's either on or off, and it's going to be at its brightest or it's going to be always at its lowest. You can do a very, very, very small adjustment to the code, which is simply adding this if-else statement, which basically says if the light level is less than the constrained max light level divided by 2. So remember, we constrained it between 0 and 255 instead of the other wide range of values. If it's between 255 divided by 2, which is about 128, then we're going to write to there. If it's less than, meaning it's darker in the room, we're going to write, hey, set it to 255 and make it bright in there. Else, we're going to write 0, meaning turn it off. And that's about it. This is the only difference in the code, and other than that, everything else should be the same. And next, I'll show you a couple of examples of them in action. so that concludes the video. As you can see, it's all wired up. It works well. And I will see you guys in the next video. Thank you so much.